So the second part of section 4.1, or at least the part that I'm going to make a second part, starts to get into some overlap from earlier in the course. We talk about like terms. We say that like terms are terms that have the same variable structures, which means they have the same variables and the corresponding variables have the same exponents. The coefficients don't need to match. Terms are not like terms if either they have different variables or if the corresponding variables have different exponents. So 3xy and 5xy, they have exactly the same variables. They have both an x and a y, and the x has an exponent of 1 in both, the y has an exponent of 1 in both. Those are considered like terms. Whereas 8a squared and 5a, they're not considered like terms. I'm not looking at the coefficients, I'm looking at the variables. You have to have the same variables and the variables need to have the same exponents. So 8a squared and 5a are considered not like terms because they have different exponents. Similarly, negative 4x squared y and 3xy aren't considered like terms. It has nothing to do with the negative 4 and 3, the coefficients. It has to do with the x's not having the same exponents. 7x and 8x are like terms because they have exactly the same variables, both just a single x, and the x's have the same exponents. 5x squared and minus 14x squared, also like terms, same variables with the same exponents. 6x and 6y, not like terms because you have different variables. This we already know. In the world of adding and subtracting with, now we'll use a better name, monomials, you add or subtract only when you have like terms, and you add or subtract by adding the coefficients in an adding problem, subtracting the coefficients in a subtracting problem. So if I was asked to add 3x and 5x, those are like terms, they can be added. I add the 3 and 5 and get an 8, I keep the x. In the second example, 8xy squared and 11xy squared, those are like terms, they can be added. I add by adding the coefficients, and I don't change the variable part. 24z squared minus 15z squared is a subtraction with like terms. They can be subtracted. I subtract the 24 minus 15 and get a 9 and leave the z squared. The next example, 3x plus 1x plus 5x, is adding 3 like terms. As long as the terms are like, you can add or subtract as many of them as you care to, just by adding the coefficients or subtracting the coefficients if they're subtractions. This 3x plus 1x plus 5x, I'd go 3 plus 1 is 4, plus 5 is 9, and make this 9x. Similarly, this trinomial right now has all like terms. I'm going to use orders of operations to simplify. I'm going to do 10y minus 4y and get 6y. And then I'm going to do 6y plus 3y and get 9y. So the first 1, 2, 3, 4, 5 of these bullets have adding or subtracting with like terms. Super easy to do. The next two problems, 8x squared plus 5x and 3y cubed minus 8y, they can't be added or they can't be subtracted because I don't have like terms. In order to add or subtract, you have to have like terms. I don't have like terms there, so I can't add or subtract. That's not new. This is gonna be new because we didn't beat on this a little bit earlier this semester. When we're dealing with polynomials, there's a custom way to, or a customary way to write the terms. And usually we write the terms in order of their degree from highest degree to lowest degree. So this polynomial, which is another polynomial because it has 4 terms, it has a first degree term of 5x, a 0 degree term of negative 3, a third degree term of 8x cubed, and a second degree term of negative 5x squared. This is not written in the classic standard form. The standard form of a polynomial is to write it so the terms are going in from highest degree to lowest degree. So I'm taking the time to rewrite this in a better order, in a more customary order. The polynomial that I've written under this, the first term is a second degree term. The second term is a third degree term. The third term is a first degree term. And the fourth term, the constant, is a 0th degree term. So if I want to write this in a nice order, I'd have the third degree term written first, the second degree term written second, and the second degree term didn't have a sign in front of it, but it has to have a sign in front of it when it's not written first, and since it's positive and not negative, I put a plus sign in front of it, and then I wrote the first degree term, and then the constant. That's going to be new. The next few problems that we're going to get have to do with adding polynomials, and I took the time to write parentheses when I probably shouldn't have. Parentheses, if a polynomial is written in front of a parentheses and there isn't a coefficient preceding, so if there's no coefficient preceding the parentheses, I don't know if I could spell preceding. Probably can't. I'm going to write before so I don't look as dumb as I am. If there's no coefficient before the polynomial, if there's no minus in front of the polynomial, and if there's no exponent outside the polynomial, if I have a parentheses, if you're given a parentheses, and it doesn't have any of these three, the parentheses can be dropped without changing any signs. So if you don't have any one of these three, then you can just drop the parentheses without changing signs. If you had any one of those, a coefficient before the parentheses, a minus in front of the parentheses, or an exponent outside the parentheses, you'd have to change the contents before you can get rid of the parentheses. So if I was asked to add these two trinomials, both trinomials fit. They don't have a coefficient before, they don't have a negative in front, they don't have an exponent. I can just drop the parentheses. And once you get the parentheses dropped, you need to combine like terms. And I took the time to show you what I was going to combine. I was going to combine the 5x squared and the 8x squared because those are both like terms. I'm going to combine the minus 7x and the positive 9x. And I'm going to combine the constants of 3 and minus 10. Normally, I wouldn't write this next line, but just because I wanted to emphasize what I'm combining, I'm emphasizing. And then I'm going to either add or subtract the coefficients. I'm going to add the coefficients if the signs are the same. So for the x squared terms, I added the 5 and 8. For the x terms, because the numbers had opposite signs, I subtracted the 9 and 7 and got the sign of the bigger. And similarly for the constants, because they had different signs, I subtracted and took the sign of the larger. And I wrote the problem's answer with a second degree term first, a first degree term, and then my 0th degree term. The next example, parentheses can be dropped. And I have this term and that term that are like terms. I'm going to add those, and that's a third degree term. It turns out to be the highest degree. I'm also going to combine the like terms of 2xy minus 4xy by going 2 minus 4 and that's a second degree term, and I wrote it second. And lastly, I took the positive 3x and negative 10x, did 3 minus 10 and got negative 7, left the x, and that was a first degree term. So I dropped the parentheses without doing any modifications. Combined like terms, wrote my answer in a nice order. I'm not going to do too many of these because my videos get too long, and we already kind of beat on these earlier this semester. So for problem 40, to simplify this, I'm going to drop the parentheses without doing any modifications to what's inside the parentheses because I don't have a coefficient, an exponent, or a minus to deal with. And now I'm going to combine like terms and write them in a nice order. I'm going to combine the 3y and the 7y. I'm going to combine the 15 and the 8. This is going to give me 10y plus 23. I'll do the same for 42. First parentheses as well as the second parentheses can just be dropped. When I'm writing the second parentheses contents, or the trinomial inside the second parentheses, I snuck 1 in front of the x terms because I knew I needed it. So now I'm going to combine the negative 2x squared plus the 1x squared. I'm going to combine the negative 3x plus the 1x. I'm going to combine the minus 5 and minus 2. If the coefficients have opposite signs, you subtract and take the sign of the larger. This first one, the coefficients have opposite signs. I subtract negative 2 minus plus 1 is going to be negative 1, and I leave the x squared. I'm going to write that term first because it's the highest degree. In the middle terms, minus 3 plus 1 is minus 2. That's going to go in front of my x. And for my constants, both the numbers are negative. I'll keep them negative. So the answer that I would write for problem 42 would be one of these two. I like writing the negative 1 preceding the x squared. Let's do 45 together and then move on to a new group of problems rather than doing so many of these. And I probably could do 45 without dumping the parentheses. I can imagine my parentheses being gone. I'm going to add 8xy plus 17xy by adding the 8 and the 17. Part of my answer is going to have a 25xy. So I'm being lazy and not dropping the parentheses. I can visualize that parentheses dropping. I'm going to subtract 4x squared y minus 3x squared y and get 1x squared y. And then I'm going to subtract 3 minus 3, and that's going to give me 0, so I'm not going to write the constant. So the two terms in my answer are 1x squared y and positive 25xy. When I go to write my answer, I need the higher degree term first to be in standard order. The x squared y term has a degree of 3, while the 25xy term has a degree of 2. So this would be a fine answer. Similarly, this would be a fine answer. There are more problems, but I think we've done enough of these. You don't need to do all the odd problems in this grouping if you don't care to. The next two problems are going to be subtraction problems. I might actually get a part 3 out of this video, and I will. Well, that's really unfortunate. The next two problems are subtraction problems. And before I subtract, if I have a parentheses that has a negative in front of it, to clear the parentheses, I either just find the opposite of the contents of the parentheses, change each term's sign, or I think of that as being a negative 1 in front of my parentheses, and then I multiply each of the coefficients by negative 1. So these two are equivalent to each other. One way to get rid of it is just drop the parentheses, change all the signs. Another way is to say this is negative 1 times 8x squared and negative 1 times 5x and negative 1 times negative 3. It's still going to give me that. The next few problems are subtraction problems, and in the world of subtraction problems, I have to be careful when I get rid of in subtraction problems that have parentheses. I need to be careful and drop the parentheses properly. So this subtraction problem that I created, when I look at the first parentheses can just be dropped. It doesn't have a negative in front of it. It doesn't have a coefficient. It doesn't have an exponent. So if I'm simplifying this to get ready to combine like terms, I do parentheses first. First parentheses can just be dropped. Second parentheses, because it has a minus in front of it, I need to flip the sign of each term inside the parentheses to get rid of the parentheses. So the positive 3x squared would change to negative 3x squared. The negative 8x will change to positive 8x. The negative 10 will change to positive 10. Now I can combine like terms. The like terms would be the 10x squared minus 3x squared, which will give me a 7x squared. That's the highest degree, so it's going to be written first. And then the minus 2x plus 8x is going to give me a positive 6x. And then the minus 3 plus 10 is going to give me a plus 7. So that's what I'm about to do next. I'm going to avoid this example. You can look at it, pause the video, and walk through it with me if you care to. But I'm going to do a handful of problems between 49 and 58, and then pause the video and do a part 3, not letting this part get so long. So if I'm doing problem 50, first parentheses I can drop without changing the contents. Second parentheses, I need to flip both the signs, find the opposite of each term. So I'm going to make it minus 8 minus 7y. I can write an answer from here, but if you need to, show the grouping that needs to be done. This is going to be 3y minus 7y and plus 15 minus 8. The y term's going to be written first. The 3y minus 7y is going to be negative 4y. And 15 minus 8 is positive 7. For 52, first parentheses I can drop without changing the contents because it doesn't have anything that would force me to change the contents. Second parentheses, the minus in front causes me to flip signs. I'm going to make it minus x squared minus x and plus 2, and you'll notice I snuck ones in front of my x's. And now I'm going to need to combine the like terms of minus 2x squared and minus 1x squared. I need to combine the like terms of minus 3x and minus 1x. And I need to combine the like terms of minus 5 and positive 2. The signs in front of the variables are the same. I add and keep negative. So the coefficient of the x squared term is going to be minus 3. The coefficient of the x term is going to be minus 4. And the constant is going to be minus 3. That would be my answer for 52. We'll do one more of these, and I'll pause the video and we'll do a part 3 because we get into some function notation. And let's just do 55 together, and we'll call that the end of this grouping. But you should do any more of the odds if you feel like you need it. But I think we've had this skill before. Now I'm just adding the little twist of getting rid of some parentheses, writing the terms in a proper order. But it's not particularly new. It's probably not worth, spending gobs of time. It's one of the rare times this term that I'll skip on problems because I don't think you need as much. So I dropped the first parentheses, left the contents the same, flipped the signs on my second parentheses. Now I'm going to get the terms combined, and I forgot a y here. I'm going to get the terms combined and get the order dealt with. So I'm going to combine 4x squared y with 3x squared y and write that first because that's a third degree term and that's going to be the highest degree term. So that 4x squared y that I forgot to write and 3x squared y add up to 7x squared y. I should be writing equals because what I'm writing is equal to the line above it. And then I'm going to do the second degree term of 8xy minus 17xy. I'm going to go 8 minus 17 and get negative 9 and leave the xy. And then I have the constant, can't barely see it, of plus 3 and plus 3. That's going to give me a plus 6. So I'll call this the end of part 2. And you're welcome to do problems 53 if you want, problem 57. If you don't feel you need the problems, you don't need to do them. In 57, all 4 terms are third degree terms. It won't matter which one you write first in your answer. There isn't like a preferred, I need to write this third degree term first and that third degree second. When you have terms with equal degree, it doesn't matter which one you choose to write first and which one you choose to write second.